So I said that whenever you are asked to find anything inclined plane, there are basically 4 cases. So let's say I have this object this way, and let's say I have it when it's also here, but this time around is, let's say, somewhere here. Now let's make provision for a case where I have this inclined plane. That is, I'm using everything this direction, so you don't get confused, but let's just use one that is in this direction. Let's say I have this here, and this time around I have it here. We are not trying to prove how to get the forces now. We are just checking the cases, how the questions can come. So let's say I have this tied up here. Let's say I have this tied down here, and let's see the force is applied this way, and let's see here, let's see over here, force is applied this way, and let's see this one, let's see right here, force is applied this way, and here the body is at rest. So that means when the body when the mass is moving downwards, and I want you to know that we are considering that friction is present. So here, when the body at rest, so these are the 4 ways. So let's say this is case 1, case 2, so notice that here I don't want to use force. I don't want to use that what I have here is force. Let's say this is moving upwards. The body is moving upwards. Up. Why am I not using force? I'm not using force because I'm not considering external force here. Rather, what I'm checking is the forces that acts on this naturally in this position. So here also, I will not use force. I'll say when moving down, when the body moving down, but tight to an object. So let's see, this is my case 4. So let's say this is my case 3. When the body moving upwards. So let's start with case 1. When the body is at rest. So when the body is at rest, you will notice that if the body is at rest, normal reaction is acting here. If it's at rest, this normal reaction and friction and the weights, everything acting in the y and x axis, then gravity, sorry, this way, gravity acting this way on this body, then all the components acting here. You see that this body, if this is the ground, provided this body does not fall over, it will just stay here, nothing is happening to it. But the minute, yes, as is here, so the static friction is just there. So we say that in this case, frictional force, which is static friction, will be equals to force at this axis, and force acting on this axis is force at x axis, which in the earlier example we used wx to represent it. So static force is equals to force on the x axis. So you see that what this thing means is that as this object is here, static force is acting that even if it starts, you move it up or it starts moving down, it can't move. So the force that if it's moving down that wants to go this way, and the one that wants to go this way is at rest, so nothing is happening there. So I say that they are equal, which means that Wx minus Fs is equals to 0. So as the body wants, naturally the body tends this way, static force will want to go in this direction. As it's coming this way, it will want to go in opposite direction. But see, because it's at rest, nothing is happening. So we can use this now, we can expand this. We know that frictional force makes account for is directly proportional to normal reaction. And when you introduce proportionality constants, static friction becomes mu s times normal reaction. I remember from the earlier example, normal reaction is mg cos theta. Then you have your mu s. So it means that this is equals to this. I can use this. I can also use this. And then Wx, if you remember, Wx is equals to mg sine theta. So I can simply say, so if this cross equality sign, it becomes this. So it becomes Wx equals to Fs. You can simply say mg sine theta is equals to, what is this? So now that I have this here, I can say cancel, 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 cancel. So I have sine theta is equals to mu of s. Coefficient, this is also called coefficient of static friction, cos theta. So divide both sides by cos theta. See that coefficient of static friction is equals to sine theta over cos theta is something as saying tan theta. You see it? So you need to note that. So that is for case 1. So for case 2, which is what I have here. If this body is moving down, like once I apply this, and definitely for this body to be here, if it's moving down, when the body is moving down, mg, the force acting on this will be mg, or you say force at x-axis. That is saying mg, the weight will be coming there, the weight will be moving there. This is the only force acting here. But this mg is acting at an angle because this body is inclined at an angle, and we've gotten that to be sine theta. The angle there is sine theta. So that means that we can say that this is Wx. Let's use what we've used. So Wx. Now, if this thing is coming here, notice that friction always acts in opposite direction. That means friction should be going this way. And the friction that will be here, is kinetic friction. The friction on an object when it's moving is kinetic friction. And remember that kinetic friction is directly proportional to normal reaction. Kinetic friction is equals to coefficient of kinetic friction times n. So remember, we have these forces. These are the forces that will be acting on this object as it's moving downwards. So we check the forces that act on the object before we start talking about the motion. So we've gotten the forces. So this is going to be forces on the object this object is going to be Wx is going in opposite direction. I normally told you, since it's moving down, forward minus backward minus Fk is equals to ma. This is the force of the system. Somebody will want to ask me, where did the ma come? I told you earlier that anytime you're talking about force is equals to ma. So if I notice, it's not every time that force is F this side. If I have many force or something happening, so the forces on the left hand side will still be equals to ma, mass and the acceleration. So notice that here I have force on the x-axis which is going this way, and I have the frictional force. By the time I do everything, it should be equals to ma. So making like terms now, you see that this now will be the same thing as saying Wx is equals to crossing over Fk. Fk now, remember that this n is equals to mg cos theta. So this is going to be the same thing as saying Wx equals to coefficient of kinetic friction times mg cos theta. And this one is supposed to be mg sine theta. So what touch? You see it's mg sine theta for this one. So you see that this can be the same thing as saying yes. Okay, yes. Watch. But look at this. Let's not forget something. Is equals to Wx is equals to minus Fk is equals to Fk. Then notice that this Fk came and met ma, should be plus, as it moved, ma. So plus ma. So this is going to be the same thing as saying half mg sine theta, this one crossover, minus ma equals to coefficient of kinetic friction, then mg cos theta. Divide both sides by mg cos theta. This is the same thing as saying yes. This is the same thing as saying mg sine theta all over mg cos theta equals to m minus ma over mg cos theta equals to coefficient of kinetic friction. This will cancel this. Sin theta over tan theta over cos theta is tan theta, minus this will cancel this. So you now have a over g cos theta. Watch. Then equals to coefficient of kinetic friction. Let's check if we are correct. we have MA here. Equals to this. So this came over. So you can see that when it came over, we now have this, everything here. So this and this plus, even if you whichever way. So when this one now cross over to come and meet f of k, what if we did, I want to check something. What if that time that we were here, we simply did, okay, yes, assuming we did all over, this one will have minus, yes, okay, which will still come over. Okay, so this is our final answer. So this is our final answer. So whenever you're finding coefficient of kinetic friction, that's what you always be asked to find in most cases. You see that this is how you go about it. This is how you go about it. So there you have it. You know that this thing now that I have here can also be the same thing as saying g cos theta tan theta minus a all over g cos theta. Because if this come over here, if this will cancel, then come and times a. Then if this come over here, it will meet 1, then times this. So this thing is the same with this. So whichever way you want to understand it, it's still the same thing. The same thing. So let's move to case 2. Let's try to look at case 2. For the case 2, okay, case 3, sorry. When the body is moving upwards. If the body is moving upwards, notice that the force acting here is mg, and it's happening at an angle. So it's mg, and this time around is at x-axis, and the component of x-axis when it's inclined plane is sin theta. Or you see force here, the way we found it. So it's going to be wx, the force on x-axis. Or you say weight on x-axis. Then, so I prefer to use force on x-axis, whichever way. But let me just use w since we've started with w. So plus, if this body is moving up, as it's moving up, friction with bad belly, I told you, is always going against, opposing. It will be moving this way, and the friction here will be kinetic friction, because the friction possessed by a body that is in motion is kinetic friction. So this will be f of k, and I've shown you how to get f of k. So is equals to, everything here is the same thing as when you say force equals to ma. So force acting on this body in this case is equals to ma, mass and acceleration of the body. So for that reason, wx is mg sine theta plus fk, coefficient kinetic friction is coefficient of kinetic friction times mg cos theta equals to ma. And now I've shown you how to get this. And n is equals to mg sine theta. So is equals to mg cos theta. What are you doing? So carry it and put it. So that is how you get that. So this is going to be the same as in m So Wx plus Fk equals to Me mg sin theta plus so Wx is mg sin theta, this one is mg cos theta, K. So this is going to be the same thing as saying half MA, this one crossing the quantity sign becomes minus mg sin theta. Then you can divide both sides by mg cos theta. Which means that coefficient of kinetic friction is equals to MA over mg cos theta minus mg sin theta all over mg cos theta. So this will take care of this. This will take care of this. So you have coefficient of kinetic friction is equals to A over g cos theta minus tan theta. Sin theta over cos theta is tan theta. And this is also equals to A minus tan theta times g cos theta. If you take the LCM all over g cos theta. So that is for that. So this is how you go about when this body is moving upwards. Now when this body is such that you have this is supposed to go this way, but there is something holding it back. You can see that at this junction, watch, mg will be going this way. This mg will be going this way. Now whatever it is that is holding it now, this thing that is holding it, this thing will want to come down, then this one will be exacting force on it. So we can see that in this case, you can see that right here, the total force on this system, even the friction self that is going this way, will be going this way. As it wants to come down, this one will want to go this way. But notice that everything here will be equals to 0. So we can say that, let's say we'll call this T2. So it's going to be in such a way that we have mg minus T2 equals to MA. And here A is 0. And there's no acceleration there, no movement. So it's equals to 0. So mg minus T2 equals to 0, which means that mg, and notice that the mg here is the same thing as saying, this mg is the same thing as saying wx. So it's supposed to be happening at x component, so it's mg sin theta, not just mg. So mg sin theta, minus T2 is equals to 0. So which means that mg sin theta is equals to T2. So the force acting this way on the x-axis is equals to the force acting upwards. So depending on what you are given, that's how you go about it. So if you are given m mass, given an angle, you can use it to find the force here because gravity is always constant.